Hello everyone, I'm Anushka of PSC first year from Isabella Thoburn College, and my topic is asymptotes. And here in this video I'll be discussing about asymptotes, its definition, its types and methods to solve them, and also some examples based on it. So let's start. Okay, so asymptotes, first its definition. An asymptote of a curve is a straight line which touches the curve at infinity, or we can say it is a line which is at a finite distance from the curve and meets the curve at infinity. That is, it is called tangent at infinity. Asymptotes are of two types. First one is horizontal or vertical asymptotes. Those asymptotes which are parallel to the coordinate axis are called vertical and horizontal asymptotes. Horizontal asymptotes are parallel to the x-axis while vertical asymptotes are parallel to the y-axis. Next one is oblique asymptotes. Asymptotes which are not parallel to coordinate axis are known as oblique asymptotes. Next topic is number of asymptotes. So number of asymptotes is determined by the highest degree of the equation of curve. It means that if a curve is of degree n, then it would have maximum of n asymptotes. Suppose in this equation y cube minus 6xy square plus 11x square y minus 6x cube plus x plus y is equal to 0. It is of degree 3, so it will have 3 asymptotes of the type y is equal to mx plus c. That is, they are y is equal to m1x plus c1, y is equal to m2x plus c2, y is equal to m3x plus c3. Next up is oblique asymptotes. As I have told before, oblique asymptotes are not parallel to any of the axes, that is x-axis or y-axis. So here in this, we'll see the way to solve them. There are two ways for solving it. First is long method and the second one is the short one or general method. Starting with the long method, here is the working rule for it. Let a function f of xy is equal to 0 be given. Then in the equation of the curve, put y is equal to mx plus c and arrange the equation in descending power of x. Then the coefficient of two highest degree terms of x, that is xn and xn minus 1, is equated to 0. Solving these two equations, we'll get the value of m and c and then substitute it in the equation y is equal to mx plus c. This will give asymptotes of the curve. So we'll understand that method by taking an example. So find the asymptote of the curve x cube plus 2x square y minus xy square minus 2y cube plus xy minus y square minus 1 is equal to 0. So here in the place of y, first we'll put y to be mx plus c. So we get x cube plus 2x square mx plus c minus x mx plus c whole square minus 2 mx plus c whole cube plus x mx plus c minus mx plus c whole square minus 1 is equal to 0. Then after expanding and solving it and then rearranging it in descending order of x, we get x in bracket 1 plus 2m minus m square minus 2m cube plus x square in bracket 2c minus 2mc minus 6m square c plus m minus m square plus x into its coefficient plus constant term is equal to 0. I have not written the coefficient of x as well as constant term as we are concerned only about the highest and second highest degree of x. So now we'll equate the coefficient of x cube and x square. So it will come 1 plus 2m minus m square minus 2m cube is equal to 0. This is denoted by equation 1. And 2c minus 2mc minus 6m square c plus m minus m square is equal to 0. This is denoted by equation 2. So from equation 1 we get, after factorizing it, 1 plus 2m, 1 minus m, 1 plus m is equal to 0. So the values of m are minus 1 upon 2, 1 and minus 1. Then from equation 2 we get c to be equal to m square minus m upon 2 minus 2m minus 6m square. Now we'll put the values of m and find the corresponding values of c. So when m is equal to 1, c will come out to be 0. When m is equal to minus 1, c will be minus 1. And when m is equal to minus 1 upon 2, c will be 1 upon 2. So the equation of asymptotes will be y is equal to x. Next will be y plus x plus 1 is equal to 0. And the third one will be 2x plus x minus 1 is equal to 0. This method discussed was long and very time consuming, so here is a shorter method for finding oblique asymptotes, and this is usually used for solving it. So the working rule is, first of all we'll put x is equal to 1 and y is equal to m in the highest degree term of equation and find phi and m, and similarly we'll put x is equal to 1 and y is equal to m in second highest degree term, that is n minus 1th degree term, and find phi n minus 1 m. And then we'll put phi and m to be equal to 0 and find the values of m. Now if we'll see that the values of m are distinct, then we'll find the value of c by this equation, which is c phi dash nm plus phi n minus 1m is equal to 0. If two of the values of m are equal, then the value of c is calculated by c square upon 2 factorial phi double dash nm plus c phi dash n minus 1m plus phi n minus 2m is equal to 0. Now if three of the values of m are equal, then the values of c can be found by c cube upon 3 factorial phi triple dash n m plus c square upon 2 factorial phi double dash n minus 1 m plus c phi dash n minus 2 m plus phi n minus 3 m is equal to 0. Now we'll solve some questions to understand it. Question is, find the asymptote of the curve y cube minus 3xy square minus x square y plus 3x cube minus 3x square plus 10xy minus 3y square minus 10x plus 7 is equal to 0. So on putting x is equal to 1 and y is equal to m, we get in 3 degree term phi 3m is equal to m cube minus 3m square minus m plus 3, and in 2 degree term phi 2m is equal to minus 3 plus 10m minus 3m square. So now we'll put phi 3m to be equal to 0. We'll get m cube minus 3m square minus m plus 3 is equal to 0. We'll take m square common in first two terms and minus 1 common in the last two. We'll get m minus 3, m square minus 1 is equal to 0. Then the value of m will come out to be 3 minus 1 and 1. Now the value of c is given by c is equal to minus phi 2m upon phi 3 dash m, which is equal to minus in bracket minus 3 plus 10m minus 3m square upon 3m square minus 6m minus 1. So putting m is equal to 3, we'll get the value of c to be 0. So the equation will be y is equal to 3x plus 0, then y minus 3x is equal to 0. Putting m is equal to 1, the value of c will be 1. So the equation will be y is equal to x plus 1, that is y minus x minus 1 is equal to 0. Then at last, putting m is equal to minus 1, the value of c will be 2. So the equation will be y is equal to minus x plus 2, that is y plus x minus 2 is equal to 0. These are the three asymptotes for the given curve. Here is another example for this method. In the last question, all the three values of m were distinct. Here we will see when two values of m are same. So the question is, find the asymptote of the curve x cube minus 5x square y plus 8xy square minus 4y cube plus x square minus 3xy plus 2y square minus 1 is equal to 0. On putting x is equal to 1 and y is equal to m in the term of highest degree, that is phi 3m is equal to 1 minus 5m plus 8m square minus 4m cube, and phi 2m is equal to 1 minus 3m plus 2m square. Now putting phi 3m to be equal to 0, we get 1 minus 5m square, sorry, it is 5m. So 1 minus 5m plus 8m square minus 4m cube is equal to 0. Taking minus sign common, we get 4m cube minus 8m square plus 5m minus 1 is equal to 0. M minus 1 is a factor of equation. As for m is equal to 1, the value will come out to be 0. So m minus 1 bracket 4m square minus 4m plus 1 is equal to 0, which is equal to m minus 1 to m minus 1 whole square is equal to 0. Value of m will be 1 and 1 comma 2 comma 1 comma 2. So here we see that two values of m are same, that is m2 and m3 are equal to 1 upon 2. So first we'll find the value of c1 from the same method, that is c is equal to minus phi 2m upon phi 3 dash m, that is equal to minus in bracket 1 minus 3m plus 2m square upon minus 5 plus 16m minus 12m square, which is equal to minus in bracket 1 minus 3 plus 2 upon minus 5 plus 16 minus 12, which will come out to be 0. So the equation, so putting in equation y is equal to mx plus c, we will get y is equal to x plus 0, that is y minus x is equal to 0. Now since m2 and m3 are same, we'll get two parallel asymptotes as the slope is same. For finding different constant value, we'll use the formula c square upon 2 factorial phi 3 double dash m plus c phi 2 dash m plus phi 1 m is equal to 0. It will be c square upon 2 in bracket 16 minus 24m plus c minus 3 plus 4m, and since there is no 1 degree term, it will be 0, which will be equal to 0. So putting the value of m, now 1 upon 2, we'll get c square upon 2, 16 minus 12 plus c minus 3 plus 2 is equal to 0, that is 2c square minus c is equal to 0, and the value of c will come out to be 0 and 1 upon 2. So the equations will be y is equal to 1 upon 2x plus 0, that is 2y minus x is equal to 0, and y is equal to 1 upon x plus 1 upon 2, 1 upon 2x plus 1 upon 2, which is equal to 2y minus x minus 1 is equal to 0. These are the three asymptotes for the curve. Now next type of asymptotes are those which are parallel to the coordinate axis. First one is asymptotes parallel to the x-axis. So for finding it, here is the working rule. Asymptotes parallel to the x-axis can be obtained by equating to 0 the coefficient of highest degree terms in x, provided it is not a constant. If the coefficient of the highest power of x is either a constant or has its linear factors all imaginary, then the curve has no asymptotes parallel to the x-axis. Next type is asymptotes parallel to the y-axis. The working rule is asymptotes parallel to the y-axis can be obtained by equating to 0 the coefficient of highest degree terms in y, provided it is not a constant. If the coefficient of the highest power of y is either a constant or has its linear factors all imaginary, then the curve has no asymptotes parallel to the y-axis. Question based on it. Find the asymptotes parallel to the axis of the curve x square y square minus a square in bracket x square plus y square minus a cube x plus y is equal to 0. Opening the bracket, we get x square y square minus a square x square minus a square y square minus a cube x minus a cube y is equal to 0. So for asymptotes parallel to the x-axis, the coefficient of highest degree term of x is y square minus a square. So we'll equate it to 0 and we'll get y is equal to plus minus a as the asymptotes parallel to the x-axis. And for asymptotes parallel to the y-axis, the coefficient of the highest degree term of y is x square minus a square. So putting this coefficient to be equal to 0, we get x is equal to plus minus a, and this is the asymptote parallel to the y-axis. And along with that, it was the end of my topic, and thank you so much.